Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 1.9 entitled Graphing Calculators. And what we're going to do today is we're basically going to use our graphing calculators to solve equations and inequalities graphically. And you should be familiar with how to do this. If not, this will be something new for you, but I'm hoping it's a review and it's just to remind you about how to use the different features of the table and what they mean and how to use the intersection and the zero capabilities on your graphing calculator. Now when we use a graphing calculator, we have to remember that we can plug in equations and we can graph them and we can see them. However, that screen that we're looking at, it's called the viewing rectangle, and it's a rectangle. Even though we can set it to any kind of dimensions we want, that view isn't going to be 100% accurate all the time. So we do have to remember that we need to estimate what's on the calculator, and we might need to adjust what we're viewing as well. And the way we adjust our view is to adjust the maximum and the minimum x and y values. And I'll show you how to do that in the calculator, but it's in the window menu. And you can change the minimum x value and the maximum x value. And then you can change the minimum y value and the maximum y value. That way you can shift your graph to the left or the right or up or down. You can zoom in or zoom out. You can also change the scale, so you can see every 1 unit, or you could see every 100 units, or you could see every 0.01 units. So our first example here is just going to be a little bit of a reminder, a little bit of a refresher. It says to graph our equation, y equals x squared plus 3. And I'm going to go right to my graphing calculator. And to graph, we want to go to y equals. Now I'm using the TI-84 Plus because that's what the software is programmed with. You might have an 84 Plus, you might have an 83. They're fairly similar. The 84 Pluses have a few more technological advances, and sometimes the menus might be in a slightly different location, or the things in the menus might be just slightly out of order, but overall they're fairly similar, and they'll be similar for this activity for today. So I'm going to go to y equals and I'm going to type in my equation. I had x squared. Remember the x button is right below the mode, right next to the alpha. It says xt theta n. So I have x and then squared plus 3. Now as I'm doing this, over to the right hand side on the screen, it'll show you all the buttons that I'm pushing to do the stuff on the calculator. Okay, now if I'm going to graph for the very first time, I want to make sure my calculator is in standard mode. So I'm going to do zoom, which is the button that's right in the middle of the ones below the screen. And then I want to do option 6 for standard. And that gives me a basic 10 by 10 window. It goes from -10 to +10 on the x-axis and -10 to +10 on the y-axis. But you'll notice there's a lot of empty space. I have a lot of my negative x values and my negative y values that I don't use, and a lot of my positive x values I don't use at all. So while we can see our graph, we can zoom in so that it's a little bit more accurate. So if you go to Window, this is where you can change your x min and your x max, your y min and your y max, and you can even change your scale. So I'm going to make my x min start at -5 and then arrow down. My maximum for x, I'll make 5. I'm still going to leave a scale of 1. My y minimum, I'm going to make that 0 because I wasn't using any negative y values at all. And then my maximum, I'll make that a little bigger. I'll make that 15. And I'm still going to keep a scale of 1. Now if I hit the graph button, now I can really see that parabola with much more accuracy. And I can tell that there's no x-intercepts, but I do have a y-intercept. And there's a couple different ways that we can find what those intercepts are, and we'll talk about those in the next examples coming up in more detail. But I do want to remind you that you can go to second graph and you can get a table of values. And remember, for a parabola, the y values have symmetry. There's a little pattern that repeats. And right in the middle of that symmetry, 0, 3 is going to be the vertex of my parabola, and that's actually going to be the y-intercept as well. So we've graphed that one on the graphing calculator. So if this was a problem in your homework, you would want to make a table of values, and you want to write those table of values down. So the table of values we saw on our screen, you need about at least 5 values to graph a parabola, I think. That's kind of the number that I use as like a rule of thumb. So you'd want to write down those table of values. Again, this was our vertex. And then you can get some graph paper and plot those points and make your parabola. Okay, solving equations graphically. Now, we can solve equations algebraically or graphically. Usually, we would solve this one algebraically. We would add the 5 over to the other side, and then we would divide by 3. So we get 5/3, which rounds to about 1.67. So when we're solving problems algebraically, we get a nice exact answer. When we're solving them graphically, it's more of an estimate. And basically all we do is we swap out that equals 0 for an equals y. And then we have to find the value of x for which y equals 0. So that's what we're going to be looking for in our table of values when we're trying to solve an equation with our calculator. And this would be the equation, the graphed form of that equation. And you can see here's my y-intercept, which is at -5. But my x-intercept is my solution, and that's going to be at about 1.7 on the calculator. I rounded to 1.67 when I did it algebraically. But basically, you have two methods then to do the same problem. You can do it algebraically by hand, or you can do it graphically on your calculator. Now again, remember, when we're solving a problem algebraically, we get an exact answer. When we're solving a problem on our graphing calculators, we have to remember that sometimes they can be very accurate and very precise and very exact, and other times they're more of an estimation. So for example 4, we have 3 parts here, and I'm actually going to start with part B. It's the directions say to solve these equations algebraically and graphically. I'm going to start with part B because it's set equal to 0 and I can factor. It's a quadratic, it's a trinomial. I have factors of 4 that'll get me to a -4. So when I factor, I'm going to have x minus 2 and x minus 2. And then when I set each of those little factors equal to 0, I'll get x equals 2 and x equals 2. And since they're the same, it's really just one answer. Now, on my graphing calculator, how I would do that is I would go back to y equals. Let me clear that out. And I'll clear out everything that's in there. And I'm going to put in that equation, x squared minus 4x plus 4. So instead of setting it equal to 0, I'm setting it equal to y. And I'm going to do zoom 6 again so that I get a nice standard graph. And there you can see again, I've got a lot of empty space here on my negative x-axis. I've got a bunch of empty space here in my negative y-axis. Some of this stuff over to the right on the positive x-axis, empty space. So I can adjust my window if I need to. And you don't really have to do this in order to find the solution to the problem. Maybe make that a little bit bigger. Let's make it 8. You can not zoom in and still find the solution that I'm going to talk about in just a moment. But let me zoom in a tiny bit. Okay, now I hit graph. There we go. And now we can see that the parabola definitely touches that x-axis. But sometimes on the calculator it's hard to tell. Is that really at 2 where it's touching the x-axis, or is that somewhere else? So what I'm going to do is I'm going to find the 0. and your calculator will do that for you. And if you go to Second, Calc, the Calc menu is above the Trace button, and option 2 is your 0. It will tell you where that parabola actually crosses the axis. Now, the calculator is going to say left bound, so that means you need to move that little blinking cursor that popped up on your screen to the left side of where you think that 0 is, and then hit enter. And then you're going to arrow over to the right because the calculator says right bound. So you're going to arrow over to the right. Doesn't matter where, you just need to be to the right of it. Hit enter again. And then the calculator says guess. That's the calculator's way of saying, are you sure you want me to get this answer? Just go ahead and hit enter again. Ta-da! There's your answer. And the calculator is even more precise than we were. It's 2.000007, but we would round that to 2. Okay, so we got the same answer that the calculator did. And we can see this on our table of values as well. If we go to second table, we want to find the y value of 0. So there, my y value is 0 when x is 2. So there's 2 ways graphically on your graphing calculator to solve that equation that we solved algebraically. Okay, now I'm going to go back to example A. Example A is already set equal to 0, but I can't factor it. I can't find the factors of 2 that are going to get me to a -4. So I have to use the quadratic formula. So x equals opposite b plus or minus the square root of b squared minus 4 times a times c, so that's a -8, all over 2 times a. And I can simplify, so that'll be 4 plus or minus the square root of 8 over 2. Now I could just type that right into my calculator and get a decimal answer, or remember we need to break down those radicals. So the square root of 4 goes into the square root of 8 2 times. So this is really going to be 4 plus or minus, square root of 4 is 2, square root 2 over 2, and then simplify that down by reducing. So we'll have 2 plus or minus the square root of 2. I do expect you to simplify your radicals completely, just like that on a quiz or a test. And now, after you've simplified it, you have less to type into your calculator anyway. So my decimals for that, if I took 2 plus the square root of 2, that'll get me about 3.42. And if I take 2 minus the square root of 2, I'll get about 0.59. So now let me show you how the calculator will do this. Now, when you graph in your table of values, you can't, well, you can make decimals appear in your table. It's not programmed to do that automatically. So if you want to do that, you have to go to second table set, and you have to change where it says this little triangle table. That means change the table. You need to change your increments from 1 to whatever you want it to be. You could change it to every 10 or every 5, or you could change it to every 0.1, 0.01, 0.5. Okay? So you can get decimals to appear on your graphing calculator, but it's going to have a lot of values then. If you're counting by every 0.01, every hundredth, you're going to have to scroll through a lot of values on your graphing calculator. This option though up here where it says table start, that allows you to jump to any value in the table. So if you kind of knew where your answer would be close to, you could jump right to that value. But I'm going to show you another method. I have to get the right equation in here first. So I'm going to clear out the one I had before, and we now have x squared minus 4x plus 2. And algebraically it was set equal to 0. Now it's set equal to y. I'm going to do zoom 6 so I can graph it in my standard window. Now, I could zoom in a little bit if I wanted to, but again, for this method that I'm going to show you to find the answers on the calculator, you don't have to zoom in. But you do have to go to second calc, and now we want to find the zeros again. And this time I have 2 of them. I have one here and one here. And again, I have to be on the left side of that left intercept, or that left 0. So the little cursor's already blinking to the left side of it, so I'm just going to hit enter. And I'm going to arrow over so that I'm on the right side of it, because it says right bound. And again, you just have to be to the right of it. Hit enter, and then hit enter again. Da-da-da! 0.0585. I rounded to 0.59. So that was my first answer that I got using the quadratic formula. Now I'm going to find my other 0. So I'm going to do second trace again. I'm going to do option number 2. Now I have to arrow over a little bit more. And again, I have to be on the left side of this intersect, or this 0. I know that this is on the right side of the parabola, but I have to be on the left side of where I think that 0 is. And then hit enter. And then arrow over so that you're on the right side of it, or above it in this case. Hit enter again, and then hit enter one more time. There we go. 3.14. Oh, I'm sorry, 3.414. I rounded it to 3.42. Okay, so the calculator is being more precise than what I was before. But again, we get the exact same answers algebraically and graphically. Now, I'm going to go to part C, and part C is a little bit different because in part A we had 2 answers, part B we have 1 answer, and part C we're actually going to get no answers. Now we get an answer, it's just a certain type of an answer. And again, I need to use the quadratic formula because there aren't factors of 6 that are going to get me to 4. So I need opposite b plus or minus the square root of b squared minus 4 times a times c, so that's going to be negative 24 all over 2 times a, so it'll be 2. Now, hopefully right now you're noticing why I don't get a real solution. And it's because of my radicand right here. I'm going to get 4 plus or minus the square root of negative 8 over 2. So it's almost the same as what I had in A. It's 4 plus or minus negative 8 now instead of positive 8. So remember, the way that we get rid of that negative is that we take it out. So that'll be the square root of 8 and the square root of negative 1. And I'm going to call that I. So I'm going to have my same answer, basically, except it'll be 4 plus or minus 2I square root 2 all over 2. And then that'll reduce down to 2 plus or minus I square root 2. Now that's a complex solution, so that means I have no real solution. So if I go to my graphing calculator, go back to y equals, clear out my old equation, let's put in that new one. It was x squared minus 4x plus 6. Okay, and then if I do zoom 6, so I get a nice standard graph. Notice that that parabola does not cross the x-axis at all. So I have no real solutions. I have to cross the x-axis or touch it if I'm going to get a real solution. And here the parabola doesn't touch the x-axis at all, so that's why I have no real solutions. So if I did this first on the graphing calculator, it would be helpful because it would tell me that I'm not going to have a real solution. But algebraically now, I can get the complex solutions. Okay, so your calculator won't tell you those complex solutions graphically. And there's the book pictures of those graphs. Okay, so now we're going to solve inequalities graphically. And basically it's the same. When we were solving inequalities by hand, we set everything equal to 0, or in this case, less than or equal to 0. And we can still do that in our calculator. We just replace the 0 with a y. And then for this example, we would have to find the values of x for which y is less than or equal to 0. So this can be a little tricky because we'll still get a parabola for that example. And since I had a less than, I need to find the part of the parabola that is less than or below the x-axis. So that's this little piece right here from -2 to -3. If it was greater than, then I would want the pieces of the parabola that are above the x-axis. So that would be the blue parts. So then I would have an or situation. I would want everything less than or equal to 2, or everything greater than or equal to 3. But when you have a problem like this, you can do it in your graphing calculator and get your solutions. And there's two ways that you can solve this inequality. One way is really nice, really straightforward. You're going to take the left-hand side of the inequality and you're going to set it equal to 0 or equal to y. So you'll have 3.7 x squared plus 1.3x minus 1.9. And then you're going to take the right side and set it equal to y, 2.0 minus 1.4x. And then you're going to graph both of those equations. Now this top equation, that's going to be a parabola. This bottom equation, it's linear, so it's going to be a line. So then you're going to find where the parabola and the lines intersect. So let me type these in. We have 3.7 x squared plus 1.3x minus 1.9. And if you hit enter, it'll go down to the next screen. Now, nice thing about the 83s is that it kind of wraps the text onto the next line when you type in a really big equation. Downside, in my opinion, of the 84s is that it just shows this little arrow. It shows you that the equation's going off the screen. So it's a little frustrating that you can't see the whole equation, but it's there. And if you wanted to make sure that you typed it in correctly, you would just have to arrow back over. Whoops, I missed the 1.4x. Okay, now again, I'm going to do zoom 6. There's my parabola, and there's my line. And it's kind of smushed all in here a little bit. So I've got a lot of empty space over here, down here, over here. So I'm going to zoom in just a little bit. So let me go from -5 to +5. And then let me change my negative values to, I don't know, like -5 to 10 should still be okay. Let's graph and see how that looks. Just a little bit wider parabola now. And the line, there you go. It doesn't look nearly as compact and smushed as the 10 by 10 screen did. Okay, so now if I'm trying to find my solutions, I have to find where the parabola and where the line intersect. I have to do the same thing over here too. Okay, so how I do this is I go back to second calc, and option 5 is intersect. Now, I have to kind of arrow over just a little bit. The calculator says first curve, and that's the calculator's way of saying, is this your first equation? So you want to make sure the arrow is on the right side of, or I'm sorry, the left side of the parabola. It doesn't really matter if it's above the line or below the line, but it just needs to be on that side of the parabola near where that intersection is. So hit enter. And then if you arrow to the right, I believe that will put the little cursor, the little blinking cursor on the line. And notice the calculator says second curve. That means they want to know what the second equation is. So this was my second equation. This was my line. So I'm going to hit enter. And then again, the calculator says guess. And that's its way of saying, are you sure you want me to do this? Just hit enter to tell it, yes, I want you to find the intersection. And my intersection is at -1.45, 4.03. Now, I'm concerned with the x value because if I'm solving this equation, this inequality, I need to know the value for x. So x is going to be -1.45 on that side of my graph. And now I need to find the other value for x. So I'm going to do the same process except on the other side. So I'm going to do second calc. I'm going to do 5 because I want to find the intersection. Now this time I need to arrow over so that I'm on the parabola, and I need it to be near where that intersection is. So hit enter. I'm going to arrow either to the left or to the right, doesn't matter. Just so the cursor's on the line. And it says second curve, so that's a note that we need to be on the other equation. So hit enter. And then guess means, yep, I want you to do it. There we go. There's our other value for x, 0.724. So if I round that, x will be 0.72. So those are my values for x. Now, the other way that I can do this is I can set the whole equation equal to 0, the whole inequality equal to 0. So if I was doing that, I would want to move everything over to the left side because I want to keep that 3.7x squared positive. So I'm going to add my 1.4x over, so that gives me 2.7x. I'm going to subtract my 2 over, so that's minus 3.9 is less than or equal to 0. And then again, if I'm going to do this on the calculator, I'm going to set that equal to y when I plug it into my calculator. So that's the equation I'm going to plug into my calculator. So let me go back one more time. I'm going to go to y equals. I'm going to clear out what I had in here. And then I'm going to type in that new equation, 3.7x squared plus 2.7x minus 3.9. Now when I graph this, I'm going to do zoom 6 again. I should get a parabola, and I do. And if I'm trying to find the solutions here for this parabola, remember, am I trying to find the intersections or am I trying to find the zeros? I'm trying to find the zeros. I want to find where that parabola crosses the x-axis. So I need to do option number 2 for this method. So I need to arrow over so that I'm on the left side. Notice it says left bound, just like what we did before. And I need to arrow over so that I'm on the right side of that, where that 0 will be. Hit enter, and then hit enter again. Look at that, negative 1.45. That's the same value that we got using the other method. And then I can find the other 0 on the right side, option 2. So I'm going to arrow over so that I'm on the left side of that right-sided 0. Hit enter. I'm going to arrow so that I'm on the right side of it. And this is kind of the tricky part. It just takes a little getting used to of thinking left side, right side. But at least the calculator prompts you that it's left bound and right bound. Hit enter and then hit enter again. And there's our other value, 0.72. That's the exact same values that we got. Okay? And now, since this inequality was all less than 0, right there, less than, that tells us that on our graph, we would want the part of the graph that's below the x-axis. So technically, when I'm solving this inequality, it's going to be an and compound inequality. So I would want all the values of x such that negative 1.45 is less than or equal to x is less than or equal to 0.72. So that's very easy to see on the graph. If we were solving it this way, once we get these two values, we'd probably want to put them on our number line. You could put the negative 1.45 and your 0 and then your 0.72. And you could test, you could put a circle there and a circle there, and you could test. If you substitute 0 into that equation, to the original equation, you would get a true statement. Negative 1.9 is going to be less than 2. So yeah, you definitely want to shade between. Okay, and that's what's going on there in the parabola. Okay, we're getting all those values between because those are the values that are less than or below the x-axis. So hopefully this was a good review for you of some of the capabilities that your graphing calculator has. Remember, our two most important features are probably the intersect and the 0. can even write those down. Intersect and then 0. Those two features in the menus in your calculator, in the calculate menu. And so your job is to practice this homework and do some graphing and really get a good handle on when you need to do an intersection and when you need to do a 0 option in your calculator to get the solution. Remember, 0 is when your graph is crossing an axis. Intersect is where you have two graphs that are intersecting and you're trying to find where they intersect. So if you have any problems, or I'm sorry, if you have any questions with those problems, come on in and see me before school.